Let's take a second now to talk about solving multiple angle equations. All right, so this is an example of a multiple angle trig equation. 2 sine 2x minus root 3 is equal to 0. Now, this is called a multiple angle equation because we have a 2 times x inside of our trig function. All right, so this is different compared to every other trig equation that we have solved so far. Instead of just having an x, we have a multiple of x. We have 2 times x. All right, when you see the word multiple in mathematics, think multiplication. All right, so we have multiplication times x. Well, to solve these types of problems, these multiple angle equations, we are going to use what is known as a U substitution. Begin solving multiple angle equations by completing a U substitution. We are going to say, let U equal whatever is inside of the trig function. So in this case, we say, let U equal 2x. All right? This is going to allow us to rewrite this equation in terms of U instead of 2x. I can replace the 2x with a U. This gives me 2 sine U minus root 3 is equal to 0. So we just took this complicated trig equation and we made it much more simple by doing a U substitution. We replaced 2x with U. Now we can begin to solve this equation for U. Well, what would we do? We would add root 3 to both sides of the equation, and we would divide by 2, giving us the sign of U is equal to root 3 over 2. And now that we have our trig function isolated, we can go to our unit circle to find the location of all of our solutions. Okay? So sine corresponds to the y-coordinate. That means we need to find angles that have y-coordinates of root 3 over 2. That's going to be pi over 3 and 2 pi over 3. These are the locations of our two solutions. But notice, however, that there are going to be an infinite number of solutions to this equation. We're not just looking for solutions on a particular interval, which means that I need to account for every single possible angle that terminates in the same location as pi over 3 and every angle that terminates in the same location as 2 pi over 3. Well, I can do that by saying u, again, we're solving for u in this particular case, u is equal to pi over 3 plus n2 pi. Notice every time I add a multiple of 2 pi, I'm going to come back to another angle that terminates in the same location as pi over 3, giving me another solution. And we also have u is equal to 2 pi over 3 plus n2 pi. That will accommodate for every single angle that terminates in the same location as 2 pi over 3. Well, these are my solutions for u. Our goal, however, is to solve for x, but we know that u is equal to 2x. So I'm going to take each one of these and now replace u with 2x, giving me 2x is equal to pi over 3 plus n2 pi. And 2x is equal to 2 pi over 3 plus n2 pi. And to solve for x, I now must divide everything by 2. Dividing by 2 is the same as multiplying by 1/2. That gives me x is equal to pi over 6 plus n pi. I do the same thing with my solution here. To solve for x, I divide everything by 2. That's the same thing as multiplying by 1/2. That gives me x is equal to pi over 3 plus n pi. And that is how we go about solving multiple angle equations. All right? Use this U substitution technique anytime you see multiplication of an angle, a multiple of an angle inside of a trig function. Let's try another one. Solve the multiple angle equation. Again, notice instead of just an x inside of our trig function, we have 3 times x. We have multiplication of an angle, a multiple angle equation. We begin by completing our u substitution. We are going to say, let u equal, in this case, 3x. right? We say u is equal to whatever we see inside of our trig function. Now we can rewrite our equation in terms of u in a much more simple manner. We have 4 cosine squared u minus 1 is equal to 0. We would now begin to isolate our trig function, cosine u, starting by adding 1 to both sides of the equation and dividing by 4. This gives us cosine squared u is equal to 1 over 4. And now we can take the square root of both sides. The square root of cosine squared u gives me cosine u is equal to, well, if I take the square root of a fraction, I take the square root of the top and the bottom, leaving me with plus or minus 1 half. Cosine u is equal to plus or minus 1 half. Remember, don't forget, anytime you take a square root of a variable, you need to include both positive and negative roots that are solutions. So at this point, we have our trig function isolated. We can go to our unit circle. We need to find the location of all of our angles that have a cosine value of positive or negative 1 half. All right, that means the x-coordinate is positive or negative 1 half. Well, that gives me pi over 3. That gives me 2 pi over 3. The x-coordinate's negative 1 half. 4 pi over 3, and 5 pi over 3. Those are my solutions between 0 and 2 pi. However, we're not just looking for solutions on the interval 0 to 2 pi. We are looking for all of the possible solutions. Well, recognize here that pi over 3 and 4 pi over 3 are pi radians apart. That means anytime I add a multiple of pi to pi over 3, I will get another solution. So one of my solutions here is going to be u equals, and again, we're solving for u in this equation right now, u is equal to pi over 3 plus n pi. Every time I add a multiple of pi, I'm going to come back to another solution. Again, this is where n is equal to any integer. All right, 2 pi over 3 and 5 pi over 3 are also pi units apart. To count for every single angle that is in either one of these two positions, we can say u is equal to 2 pi over 3 plus n pi. So these are my solutions for u. That being said, we want to solve for x. And to do so, all we have to do is back substitute in for u. We know that u is equal to 3x. I replace each one of these u's with a 3x. 3x is equal to pi over 3 plus n pi. 3x is equal to 2 pi over 3 plus n pi. And to solve for x, we need to divide everything by 3. Divide both sides of the equation by 3. And remember, dividing by 3 is the same as multiplying by 1/3. If we multiply everything by 1/3, we get x is equal to pi over 9 plus n times pi over 3. That's one of my solutions. And my other solution is x is equal to 2 pi over 9 plus n times pi over 3. All right, that is how we go about solving multiple angle equations. Again, multiple angle equations just means we have multiplication of a value inside of our trig function. To do so, we use our u substitution.